So for previous lecture, we already discussed what is queuing theory, what are the basics that are related to queuing theory, how the queuing models are formulated, what is the notation which is used for formulating the queuing model. And as we know that there is only one model included in your syllabus. So related to that model one, which is MM1 FCFS infinity model, related to that model only we are going to discuss, and related formulae I have already given. So about 15 formulae yesterday we have discussed, and what is the meaning of that. Mainly these are based on two terms, lambda and mu. What is lambda? What is lambda?
Mean arrival rate.
Mean arrival rate. What is mu?
Mean service rate.
Mean service rate. So how the customer arrives and joins the queue, and how it gets served based on their distributions. This formula have been derived, and then you have to use them as it is. So today we are going to discuss the problems. I will discuss two problems related to this, and then later on I will give you assignments. Okay, one assignment on decision theory, or in only one assignment I will include three topics: decision theory, game theory, and paying theory. And I will upload that on WhatsApp group or somewhere on Moodle, so that you just take down that and solve those questions and submit those answers on the Moodle. Is it okay? Okay, so whether my screen is visible?
Yes, sir.
Okay, so take down this problem. A self-service store employs, take down this problem. A self-service store employs one cashier at its counter. Full stop. 9 customers arrive on an average every 5 minutes. 9 customers arrive on an average every 5 minutes, while the cashier can serve 10 customers in 5 minutes. While the cashier can serve 10 customers in 5 minutes. Full stop. Assuming Poisson's distribution for arrival rate, assuming Poisson's distribution for arrival rate and exponential distribution for service rate, and exponential distribution for service rate, find first one is average number of customers in the system. Average number of customers in the system. Second, average number of customers in queue. Average number of customers in queue. Third one, average time a customer spends in the system. Average time a customer spends in the system. And fourth one, average time a customer waits. Average time a customer waits before being served. Before being served. Okay, have you taken this? Okay, now tell me what is given in the problem. We should know what? Mean arrival rate. So here mean arrival rate is required to be found. What is mean arrival rate? Is it lambda?
Yes, sir.
So arrival is 9 per 5 minutes. So how much is the arrival rate?
1.8.
1.8 customers per minute. Okay. Then you have to find out mean service rate, that is mu. Okay. So it is again 10 per 5 minutes. So it is nothing but 2 customers per minute. Now what is asked? What is the first question? Who will read it? First question.
Average number of customers in the system.
Average number of customers in the system. So in the system means it is LS. So somebody, can you read the formula of LS? Roll number 77. 77 is there.
Yes, sir.
LS is equal to what?
Lambda upon mu minus lambda.
Lambda upon mu minus lambda. So can you solve this? 1.8 divided by 2 minus 1.8.
9.
9 customers. Okay. So this is the answer. Second, what is asked? Second,
Average number of customers in queue.
average number of customers in queue. That is nothing but LQ. What is the formula for LQ? 74.
Sir, lambda square upon mu in bracket mu minus lambda.
Lambda square upon
Mu in bracket mu minus lambda.
mu into bracket mu minus lambda. So tell me the answer as well. Have you solved it? Anybody?
Sir, 8.1.
8.1. 8.1 customers. As it is length. Okay. So next, what is third? Third thing which is asked. Yes.
Average time a customer spends in the system.
Average time customer spends in the system. What is that?
WS.
WS, yes. So what is the formula for that WS?
1 by mu minus lambda.
1 by mu minus lambda. What is the answer?
5 minutes.
5 minutes. Okay, 4. 207 is there?
Yes,
20
sir.
Okay. What is the fourth thing which is asked?
Average time a customer waits before being served.
So what is that? What is that?
WB.
WB. Average time a customer waits before being served.
WQ.
Means average time a customer waits in the queue.
WQ.
What is the formula for that?
Lambda divided by mu in bracket mu minus lambda.
What is the answer?
4.5 minutes.
4.5 minutes. Okay. So can you understand how to use this formula? You need to know that what is asked and how to use that. Okay. Now take down next problem. Is it visible to you people? Green color? Okay. So take down the second one. Okay, who will read the first statement? Roll number 82.
Yes. Arrival rate of telephone calls at a telephone booth are according to Poisson distribution with average time of 9 minutes between two consecutive arrivals.
Okay, full stop. So what is given is that Poisson's distribution. If it is not given, consider that it is Poisson's distribution, as ours is related with only one model, in which arrival is Poisson's. Okay, Poisson distribution. And that arrival time, 9 minutes between two consecutive arrivals is given. Okay, full stop. We will read the second one. Second statement. 8 is there, 80?
Yes, sir.
Read it.
The length of the telephone call is assumed to be exponentially distributed, mean 3 minutes.
Okay, so length of telephone column is assumed to be exponential. It is assumed. If it is not given, you have to consider it as exponential because that is the only one model we are discussing. And it is given as mean 3. Okay. Next, 76 is there. 76. Read A, point number A or question number 1. A. 76 is there. Okay, 65. 65 is there. 65. 47. 47 is not there. 75. Read it. Okay, so what is asked is determine the probability that a person arriving at the booth will have to wait. Okay, full stop. All of you have to take down this problem. Huh? So note down this. We will read the next stage, B. 52 is there, 52. Roll number 20. 2020 is not there. How many are there? Okay, 7.
Sir, B. C. Telephone company will install a second booth when convinced that an arrival would expect to have to wait at least 4 minutes for a minute.
Or 4. Okay, and find the increase in flow of arrivals which will justify a second booth. So C is given that a second booth is required or not. If it is required to be convinced. So how to justify that? If at least 4 minutes for a phone, the customer has to wait. If that is justified, second booth will be installed. Then what will be the increase in flow of arrivals that we have to find out. Next, we will read D. (42). 42 is not there. 42, 63. Okay, 23. Read it.
Yes, sir. What is the probability that an arrival will have to wait for more than 10 minutes before the phone is free?
Okay, so we have to find out the probability. So how to find out that we will see. Next, we will read E. Point number E. 80 is there. 80. No, 82.
Yes, sir.
Find
80 is there?
Yes, sir.
Read it.
Find fraction of a the find fraction of a day. Yeah, the find fraction of a day, the phone will be in use.
The find fraction of a day the phone will be in use. So that is asked. Okay. F. 82. Read the next point.
Yes.
What is the probability that you will have to wait for more than 10 minutes before the phone is available and the call is also completed?
Okay, so it is in the service. Previously it was in queue, that was asked. Now what will be there in the service, that is asked. Okay, so whether arrival rate and service rates are given in this problem. What is lambda? Lambda is 1 by 9 per minute. Am I right?
Yes, sir.
Lambda is 1 by 9 per minute. What is mu?
1/3.
1 by 3 per minute. Okay, so that is given. Now what is asked? First one, read it, somebody. Who will read the first one?
Determine the probability
Hmm.
that a person in the booth will have to wait.
Person will have to wait means the system being busy. Somebody must be there in the system or waiting system. That means n is greater than 0. So what is the probability of n is greater than 0? What is the formula for that?
Lambda by mu.
Lambda by mu. So how much is it?
0.3.
0.33. Okay. Is it okay? Okay, next B. Somebody read the B point.
Sir, P of n greater than 0 is only lambda, no?
No, it's only row. It's only row.
Rho, yeah.
Lambda by mu. Rho is nothing but lambda by mu. Okay. Okay, 13.
Yes, sir.
Okay, tell me what is asked in B.
Find the average queue length that is formed from time to time.
From time to time. So I've given you in the formula various ways the problem is asked. So what is that? That is nothing but LP, no? See the formula.
Yes, sir. Yes.
Okay, what is LP?
Mu upon mu minus lambda.
Okay, what is the value for that?
One 1.5.
1.5 persons or customers. Okay. Okay. C. What is asking the C? I will continue on next page. C. What is required to be justified? What is required to be convinced? What is required to be convinced? Can you read the first statement of C?
The telephone company will install a second booth when convinced that company will install a second booth when convinced that an arrival would expect to have to visit at least 4 minutes for a phone.
4 minutes. So something is given as 4 minutes, and I will have to wait for a phone, not service. Service means phone call is also completed. So is it WS or WQ? So WQ, waiting in the queue. must be 4 minutes. So that is new. And for that, what is the arrival? Our general arrival is lambda. New arrival, we have to find out, that is lambda 1. And service rate is same. So WQ is equal to lambda upon mu into bracket mu minus lambda. Here in this case, lambda 1 upon mu into bracket mu minus lambda 1. That lambda 1 we are interested in finding out. If suppose WQ is 4, is it okay? So we have to find out the arrivals for 4 minutes waiting in the queue. If we find out that, and then if we justify the increase in flow of arrivals, then new boot can be installed. So how will you find out this? This will be equal to 4 lambda 1. What is mu? Mu is 1 by 3 into bracket 1 by 3 minus lambda 1. Okay. So find out lambda and tell me the value of lambda 1. Lambda is already known. Here we are finding out lambda 1. What is lambda 1?
Four by 21.
4 by 21 arrivals per minute. Am I right? Arrivals are customers or persons per minute. That is mu lambda 1 by lambda 1. Now what is asked? What is the next statement in C? What is the next statement in C?
Find the increase in flow of arrivals, which will justify a second booth.
Increase in flow of arrivals. That is required to be found out. So that is nothing but what lambda 1 minus lambda. What is lambda 1? It is 4 by 21. Minus lambda is 1 by 9. So how much is it?
5 by 63
5 by 63 per
minute.
minute. Okay. So whatever unit is there, you have to write it. So if increase in flow of arrival is 5 by 63 per minute, then and then only new booth can be justified and we can convince it. Okay, what is the next one? D.
What is the probability that an arrival will have to wait for more than 10 minutes before the phone is free?
Phone is free means in the queue. He has to wait in the queue. So probability of arrival in the queue, that is required to be found. So probability WQ is greater than or equal to W. W is what? 10, no? W is how much? 10, no?
Yes, sir.
In the
10.
problem.
Yes, sir.
So it will be equal to integration W to infinity means 10 to infinity. This is about in the queue, so lambda by mu into bracket mu minus lambda into e raised to minus mu into bracket mu minus lambda t dt. So can you solve this? So it will be equal to lambda upon mu into mu minus lambda, whatever first term is there. Then you solve this integration, e raised to minus mu minus lambda into t divided by minus mu minus lambda. It is from 10 to infinity. Is it okay? Is it okay?
Yes, sir.
Okay, so this will be equal to, again, lambda by mu into bracket mu minus lambda into what is e raised to infinity? What is e raised to infinity? When t is equal to infinity?
Raised to minus infinity is equal to 0.
0, okay. So minus into bracket. It is when we put t is equal to 10. When we put t is equal to 10, it will be e raised to minus into bracket mu minus lambda into 10 divided by, this is 0 minus into bracket mu minus lambda. Okay, now this mu minus lambda and this mu minus lambda gets cancelled. This minus and this minus will become plus. Am I right? So
Yes,
what will be this formula? This formula will become lambda by mu into e raised to minus into bracket mu minus lambda into 10. Am I right? Now can you solve it? Lambda is known, mu is known. Lambda is original lambda, not from the C. And mu is also known. Can you solve this?
0.036.
0. Yes.
036.
036. सगळ्यांचे झाले का?
हो सर.
Okay. So 0.036. Okay, next. What is the next thing which is asked?
Find fraction of a day the phone will be in use.
And a fraction of a day means it is utilization factor. Nothing but the traffic intensity. Okay. So this is nothing but rho, lambda by mu. How much is it? It is already known. Okay. Okay. So that is again repeatedly asked. What is F? What is F?
What is the probability that he will have to wait for more than 10 minutes before the phone is available and call is also complete?
Call is also complete means waiting plus service. So time in the system. So probability of WSER, not WQ, greater than or equal to 10. 10, no? What is asked? 10. It will be equal to 10 to infinity. Here rho will not be there. Means lambda divided by mu will not be there into e raised to minus into lambda t dt. Okay, now in the same manner, if you solve this, you will get e raised to minus mu into lambda into 10. So how much is it? How much is
0.1.
0.1? Okay. सगळ्यांचं हे झालं का बघा. ठीक आहे. Okay, so this way you can solve the problems and you have to focus on what is asked. So based on all these 15 formulas, something will be asked and you have to solve it. Is it okay? Now I will not go for further problems. Rather, I'll give you some problems for assignment so that you can solve by yourself. Is it okay? Is it okay?